Well, this tutorial is going to look at one of the basic aspects of Houdini, which is the handling of polygonal objects. And the reason I'm going to cover this is because it's slightly different from some of the other 3D applications out there. So let's start by laying down a box, and let's dive inside so we can see the box. Now, for quite a lot of these primitives you get an option of either a polygon or a polygon mesh, and they're more or less the same. Polygon mesh simply subdivides the polygons with more detail. Let's stick to a polygon. If we middle click on a node, we can see what the components of the geometry are that make it up. So in this case we've got 8 points, 6 primitives, 24 vertices and 6 polygons. Now, a primitive and a polygon, when you're talking about a polygonal object, are the same. It's a face. So in this case there are 6 faces and therefore 6 polygons and 6 primitives. There are 8 points, and those are clearly the corners, of which there are 8, but there are 24 vertices. A brief explanation is needed about what a vertex is, and we can see it more clearly in the details view. Let's bring one up. Now, the details view is a very useful window for examining items, attributes rather, stored in your geometry, and it allows you to view it in these 4 different ways. Detail attributes, just as a digression, are attributes which have a single value for an entire network. So in this case there would only be one detail value for the whole of the box. Primitives can have a separate value for each primitive, and here we can see we've got 6 primitives numbered 0 to 5. And then let's have a look at our points. Our points contain position information, as we'd expect. This column PW can be ignored for polygons, and there are 8 points, 0 to 7. If I then look at the vertex level, what is that? Well, this is numbered slightly differently. What this means here is that this is the 0th primitive, and this is vertex number 0. This is the first primitive, vertex number 0, number 1, number 2, number 3, and so on. So we've got 6 primitives, each of which has 4 vertices. So these correspond to unique corners for each primitive, and what this is doing, the point number, is connecting the position information that's stored in the point to a vertex. So this is saying this face here includes or is bound to points 1, 5, 4 and 0, and those will form the corners of the polygonal face. Let's have a look and see what this all looks like when we render it. And unfortunately this is rather slow on Windows, but there we can see we're getting this slightly strange effect. In fact, the cube looks more like a sphere. The reason for that is that by default Houdini renders polygons with smoothing switched on, and I don't in this case want that, so let me get rid of the render. What it's doing at the moment, and let's turn on point vertices, and we can't see anything. Let's add point SOP. A point SOP is a sort of Swiss Army knife for point attributes, and one of the things we can do is add normal information to the points, and we don't need to change the values in here. This has the effect of automatically creating a normal for each point. As we can see, we now do have some normals displayed, and they come out at an angle here. And what's going on is when we render, that normal information is being interpolated for every single point on the face, and so the normal changes as you move across the face, creating a smoothed effect. So how do we get rid of that if we don't want it? Well, the answer lies in the facet SOP, and that's available here on our polygon shelf. It's right at the end here. So if I select facet, it invites me to select the primitives that I want to facet, so I'll do that. I'll select everything, press enter. Nothing seems to have changed with our normals. Even if I turn on post-compute normals, they're still the same. Well, what we need to do in order to create sharp edges is to unique the points of the polygon. Now we can see we have 3 separate normals coming out of each point. Well, how's that been achieved? Let's middle click on our node. We can now see that we've got 24 points and 24 vertices, 6 primitives and 6 polygons. Let's have a look at our details view. Let's have a look first at the points. Now we can see that some of these points are actually in the same position. There's one which is at minus 0.5, minus 0.5, minus 0.5, and down here there's one which is in exactly the same place. So although it may look as if we've got a single point at each corner still, in fact we've got several points at each corner, and we can confirm that by turning on point number display. And if we look carefully, we can see that there's several point numbers written over each other here. So what this has done is created a unique point for each vertex, and we can confirm that by looking at the vertex view, and we can see that no vertices now are attached to the same point, whereas in the past they were. And the result of that is that when it comes to calculate the normals for the point, each point is only taking into account the face that it's attached to, and thus generating a normal at right angles to that face. Whereas earlier, when a point was shared between 3 faces, the normal was calculated by averaging the normals of those 3 faces. So the upshot should be that when we render, we get a nice sharp edge. One of the interesting consequences of having unique points is that each of the primitives in the objects becomes entirely disconnected from the others. And we can see this if we select all of the primitives and then use an edit swap. And then instead of transforming them, I'm going to use the peak operator, which moves the primitives along the direction of their normals. And if I do that, we can see that the box is split into its component parts. Now I want to demonstrate a couple of other aspects of uniquing points. First of all, to demonstrate the obvious, if we select a set of polygons and then facet, then only those polygons are made sharp. As we can see if we render, just the polygons at the bottom are sharp, the ones at the top are smooth. We can also use the facet swap to, let's select all of the primitives this time, to automatically cusp, as it's called, our polygons. And the effect of this is to decide, based on the angle between faces, whether or not the point should be unique. So here with a value of 20, we can see the bottom 2 layers are being unique and the top is still smooth. Let's render that to demonstrate it. It's quite important here for the normals to be correct for this to work. In this case, if we turn on face normals, we'll be able to see that my normals are indeed pointing out from the surface. So as we change this value, fewer and fewer polygons are faceted, and if we reduce it, more and more of them are faceted.